Okay, in this video, we're doing Calc Problem Set 72. The problems and a playlist are in the description below. Let's take a look at the problem. So you can see there's a gap there because I had to edit this as I was writing it. I gave you like some extra information that was completely unnecessary and actually was contradictory. So that's why that's there. Hopefully it's not in the PDF of the problems, but who knows. All right, at the point 3,1, dx dt is equal to 5. We want to find dy dt if x squared y plus 3y cubed minus 2x equals 6. All right, so this to me is like just an implicit differentiation problem, but we can see that the independent variable is actually t. So usually, often, I don't know if often or usually, often it will be x is the independent variable. Here t is. So I need to take the derivative of both sides with respect to t. So that's what I'm going to do. So it's d dt of the left side equals d dt of the right side. Don't forget the derivative of a constant is 0. That's actually the main mistake I see people make when they actually know what they're doing. Which is a little weird, but you know, I guess it's easy to do. All right, so for the first thing, x squared y, it's a product, so we're gonna use the product rule. So first, derivative of the second will be dy dt. And then second, derivative of the first, but don't forget, that's a chain rule problem now because the independent variable is t, not x. So we get the derivative of x squared is 2x dx dt. Now the derivative of 3y cubed is going to be 9y squared dy dt. And the derivative of negative 2x is going to be negative 2 dx dt. And then, of course, the derivative of 6 will be 0. All right, so we have a bunch of stuff we got to plug in. We know we're at 3,1. We know dx dt is 5. And we're trying to find dy dt. So if I plug in for x, I plug in for y, I plug in for dx dt. The only thing I'm missing is dy dt, so I'll just solve for that. So here goes. Plugging in 3 for x gives us 9. And then 1 times 3 times 2 is 6. And then dx dt is 5, 9. I can't keep up. I'm just plugging in. We get all this. So you can see you got 30 minus 10 is 20. Bring that over. That's negative 20. You have 18 dy dt. That's going to be negative 20 over 18. And then because we can, we'll make that negative 10 ninths. And that'll be our final answer to this one. All right, let's take a look at the next problem. Use a table, so it's a table problem. Use a table to find the answers to the questions that follow about the differentiable function f, approximate f prime, so f prime of 6, sorry. So you look at the table, you figure out where 6 would fall. It would be between 5 and 7. Slope of the secant line between those, just make sure that you're saying approximately equal to. F prime of 6 is approximately equal to f of 7 minus f of 5 over 7 minus 5. So that's 4 minus 6 is negative 2, and then divided by 2, so negative 1. All right. Pretty good. Next up, we want to prove that f prime is equal to 0 for some x. F prime is equal to 0 for some x. All right, so I don't really have a lot of options here because I only know that f is differentiable. I don't know that f is twice differentiable, which means I can't really apply the intermediate value theorem to f prime. So I'm going to have to probably use the mean value theorem. So to do that, I'm going to set it up. So I'm going to look for points where y is the same, right? Like when you're just looking at the table, like you can see at 5 and at 10, the y value is 6. So the slope between those is definitely 0, the average slope, the average rate of change. So let's set it up. So f of x is differentiable, therefore f of x is continuous. That's our setup that allows us to use the mean value theorem. So by mean value theorem, and as I mentioned, it's 5 and 10, the y value is the same. That's my tip. If you're looking for where f prime is equal to 0, always try to find those places where the y values are the same. I often forget to do that, and I do it in a much more convoluted way. That's really the way to do it. So I'm going to say that f prime, I'm going to make you not watch that. F prime of x is equal to f of 10 minus f of 5 over 10 minus 5, which is 0 for some x between 5 and 10, and we did it. That's all we had to prove. For c, it says to prove that f prime of x equals negative 1 for some x. I don't know if I was trying deliberately to contrast this with part A, where part A just says approximate f prime of 6. But the setup for A, f of 7 minus f of 5 over 7 minus 5, gave us negative 1. So we can just use that. I don't know if that was my intention. If it was, that's weird. But anyway, I'm going to do the same thing. So I'm going to assume that I hadn't done part B yet and just like go through it again. So f of x is differentiable, therefore continuous. Therefore, well, it's really, I wrote here f of x is differentiable, which implies that f of x is continuous, which is probably a better thing to write rather than therefore, but I don't think it matters either way. Therefore, by mean value theorem, f prime of x is f of 7 minus f of 5 over 7 minus 5, which is negative 1, for some x between 5 and 7. So, ordinary 5 and 7. 5 and 7. Sorry, I got confused with the previous part. I would say ordinarily, you either will find two y values that are the same, or you'll be given the interval. Like, it'll just be random, be like, hey, check between 0 and 7. When you do between 0 and 7, that's what happens. I don't know if you just heard my weekly screen time report just popped up on my iPad, and I don't even want to look at it. That's always terrifying. All right, let's look at one more problem. Find all c guaranteed by the mean value theorem on negative 1 to 2 for f of x equals 2x squared plus 5x minus 4. So it's actually unusual kind of to answer this question. Usually you're just trying to like show that f prime equals a value rather than actually find c that gives you the value. But whatever, this is what we're doing. So I tend to start these by justifying that I can use the mean value theorem. I think that's a good idea in case you are asked. You'll just never forget if you do it this way. So I'm going to say that f of x is differentiable, therefore, or implies continuous, therefore by mean value theorem. Now I'm setting it up. F prime of c equals f of 2 minus f of negative 1 over 2 minus negative 1. When you plug in 2, I think you get 2 times 4 is 8 plus 10 is 18 minus 4 is 14. When you plug in negative 1, you get 2 minus 5 minus 4, so you get negative 9 plus 2 is negative 7, so minus negative 7. And then over 3, so that's 21 over 3, that's 7. And then that'll be for some c in between negative 1 and 2. All right, now let's actually do it, right? So we're going to try to find c. That's like the idea here. So I'll find f prime, and I'll just set that equal to 7. I mean, that's like what it tells us to do. So 4x plus 5. So 4x plus 5 has to equal 7. Subtract 5 gives us 2. Divide by 4, that gives us 1/2. So x is 1/2. And then here, I want to answer for c, so I'm going to say, therefore, c is 1/2. And that's how I would do it. That's the entire problem set. A couple good questions. I hope this was helpful, and good luck.